Galvanic cell is our next topic. Now in this first slide, this picture I've used, it's the picture of the cell, but it's a very elaborate picture. I think we'll study a little about the cell first, and then we can come back to this picture and understand all the points that have been actually explained in an elaborate manner. So what's a galvanic cell? Let's start with this very simple picture. Even in lab, अगर हम ये experiment करें, that we take a simple beaker and we take a rod of zinc electrode, we take a rod of zinc and we dip it in a solution, say like copper sulfate. Between zinc and copper sulfate there will be a reaction, and you can observe, if you touch the beaker, you can see that वो beaker जो है वो गर्म हो जाएगा. वो गर्म होना किस चीज़ की indication है? That जो redox reaction हुई उस beaker में between zinc and copper sulfate, it generates chemical energy. So the device जो उस chemical energy को convert करे into electrical energy is basically the galvanic cell. If we have to define it, here I have written it. It's a device used to convert chemical energy. Which chemical energy? Which is generated after a redox reaction has taken place. As I said, this is a very simple setup. हम देखेंगे इसमें कैसे reaction होती है. एक redox reaction होती है because of which chemical energy is generated, and we convert that chemical energy into electrical energy. The cell is called as galvanic cell or voltaic cell. We have previously done electrolytic cells. In electrolytic cells, redox reactions are not spontaneous. We give them electrical energy, then only the reaction starts. So in that case, electrical energy is used to carry out the chemical reaction. What is a galvanic cell? In this cell, the redox reaction is spontaneous. So because of that spontaneous reaction, जो chemical energy generate होती है, that is converted into electrical energy. Now as far as the name is concerned, there were these two people who used these cells for the first time. One man was Louis Galvano, I think, and the other man, Louis Galvano, used it in 1788, around some date only, and Alejandro Volta was another man who used it in the early years of 1800. Thus the name galvanic cell or voltaic cell. These two guys used the device by which they converted chemical energy into electrical energy. Now this is a very simple setup of a galvanic cell, very basic setup, and the reaction we'll be talking about is this, the most common reaction between zinc and copper sulfate, and on this side we get zinc sulfate and copper. If we write the ionic reaction, this is what happens. Basically in this redox reaction, zinc gets oxidized, it loses electrons, and copper gains those electrons and it gets reduced. Now look at this, let's go back to the diagram. What we do is we take two beakers. In one we take a zinc electrode dipped in a solution of zinc ions. In this case we have taken zinc sulfate. On the other hand, we have copper electrode dipped in the solution of copper ions. We have copper sulfate in this case. The two electrodes are linked by a wire which completes the external circuit, because what happens here, it's a spontaneous reaction, and this is how it starts. Zinc starts losing electrons. It starts undergoing oxidation. Now there are two things. When zinc atom will lose electrons, one, you will get the electrons. Second, you will get the zinc divalent positive ions. Those ions are here in the solution, and electrons in this external circuit move from zinc electrode to the copper electrode, right? Now copper, what happens here, we already have copper ions from copper sulfate in the solution. Those copper ions accept these electrons and they're converted into copper metal, which gets deposited on this copper electrode. This is the basic redox reaction taking place in the cell. Since oxidation takes place here, the electrode is an anode, and reduction takes place here, the electrode is a cathode. Now we can go back to this diagram. See, what they have shown is that when the reaction is in progress, in the beginning the size is what it is, what we use of the zinc electrode and the copper electrode. This diagram is important. With the passage of time, what will happen? Since zinc is getting oxidized, ये consume हो रहा है, zinc metal from this zinc rod is getting oxidized. With time it is depleting. You can see that the size of the zinc rod is decreasing because इसका depletion हो रहा है, इसकी oxidation हो रही है. On the other hand, what is happening? Copper is getting deposited on the copper electrode. एक तो जो इसका अपना size था, more than that इस पर deposit हो रहा है जो और copper बन रहा है, जो discharge copper हो रहा है because of this redox reaction, right? Now this is the oxidation half, this is the reduction half. This cell has two halves. This is our oxidation half, this is the reaction taking place there, this is the reduction half. Together these are called as half reactions and the cells are called as half cells. They're also called as redox couples, right? Let's go back to this. Now two things are happening here. One, movement of electrons in the external circuit from anode to cathode. Now movement of electrons is the flow of current, and in this cell the direction of the flow of current, conventional current ka, is opposite. If your electrons are moving from anode to cathode, the direction of the flow of conventional current is from cathode to anode. Remember that, right? Because that is the basic principle of the cell, that will use the chemical energy to generate electricity. This is how the electricity will move. It will move in the opposite direction. You can see another thing here, it's called as the salt bridge. Why is the salt bridge there? What is the significance of the salt bridge? In this salt bridge, number one thing you need to know is, we take an inert electrolyte. We can take NaCl, we can take KCl, we can take KNO3, we can take K2SO4. The word inert here means that this electrolyte, it should not interfere with the redox reaction, right? It is not inert as in inert, but it is inert because it should not interfere with the reaction going on in these two halves of the cell, right? Now what is the function of this salt bridge? As I said, as zinc continues to get oxidized, हमें यहाँ solution में Zn2+ ions accumulate हो रहे हैं, and यहाँ पे Cu2+ ions continue getting reduced. Accumulate क्या हो रहा है? What they are leaving behind is sulfate ions. So if they stay like that, if they do not move, यहाँ पे concentration of zinc divalent positive ions की बढ़ जाएगी, यहाँ पे sulfate ions की concentration बढ़ जाएगी, and धीरे धीरे there won't be any flow of current. The cell will stop. Thus they need to keep moving. And how do they keep moving? They move through this salt bridge. As you can see, there are arrows, they have the proper direction. Zinc ions move from this direction to this direction, and sulfate ions move from this direction to this direction, thus maintaining the electrical neutrality of the cell, which is very important, without mixing of the solutions. Positive ions यहाँ से move कर रहे हैं through the bridge, negative ions move कर रहे हैं through the bridge. There is no mixing of the solutions, and in spite of that, electrical neutrality of the whole cell is maintained. That is the main significance, main importance of the salt bridge. I have written the details here, what the salt bridge is, what electrolytes we use, and what is its function. The main function being to maintain the electrical neutrality. Now let's go back to this diagram. As I said, जितना जितना zinc oxidize हो रहा है, zinc electrode खत्म हो रहा है, and this is getting loaded. Copper electrolyte is getting is getting loaded, and with passage of time यहाँ zinc electrolyte भी खत्म हो जाएगा. जो भी इस diagram में हमने zinc nitrate लिया है, इसमें zinc sulfate लिया है, it does not matter. जो भी आप substance ले रहे हो, with time ये भी खत्म हो जाएगी, which would mean that with time, when every component of the cell will get consumed, the cell will turn dead, right? So this is what will happen. With the passage of time, आपका copper rod load हो रहा है ज़्यादा, zinc consume हो रहा है, आपके components सारे consume हो रहे हैं, the cell will turn dead. This is how we can revive the cell. Now this slide of this presentation is very, very important. Obviously the whole topic is important. If you know the basic principle and the basic construction of the cell, then only you can understand this. But I would say this very clearly, that this part is the most important of galvanic cell. You will have to very well understand what this relationship is and what is the consequence, what is the effect of this relationship. Now electrical potential होता है cell का, because आपने chemical energy को जो है आपने use किया to generate electricity, there will be a certain electrical potential. Now what happens is, as long as our external electrical potential is less than E cell, ये 1.1 वोल्ट की जगह आप E cell लिख सकते हैं सीधे, जैसे मैंने यहाँ ब्रैकेट पे लिखा है. Now this is an example of Daniell cell. उसमें हम zinc ions and copper ions की concentration unity लेते हैं and E potential of that cell is 1.1. To generalize the whole thing, आप 1.1 की जगह E cell भी लिख सकते हैं. As long as that E cell electrical potential of the cell is less than the external potential, आपकी normally cell चल रही है. There is a movement of electrons from zinc rod from anode to cathode, and the current will flow in the opposite direction, as is the arrow here, from cathode to anode, right? Now we keep increasing this external electrical potential. As we keep increasing this potential, a point will reach when this external electrical potential will become equal to E cell potential of the cell. At that point of time, quite naturally, I will be zero. Flow of current will be zero. There will be no flow of current because there is no potential difference. When there is no potential difference, no current will flow. This is written here. ये आपको याद रखना है. When this is equal to this, what will happen? When this is less than this, what will happen? Now, as we are constantly increasing this external opposing potential, we'll reach to this point when E external will be greater than E cell. This is when we can revive the cell by applying and increasing external potential. जो हमारी cell dead हो गई थी, उसको हम revive कर सकते हैं if we apply an increasing external potential and it becomes greater than the E cell, then the cell starts functioning again. But what you have to remember is that now it starts functioning like an electrolytic cell. क्योंकि हम इलेक्ट्रिसिटी दे रहे हैं तब जाके रिएक्शन हो रहा है. फर्स्ट थिंग्स फर्स्ट, व्हेन इट वाज अ वोल्टेज सेल, दिस वाज अ स्पॉन्टेनियस रिएक्शन हो रहा है, तब मोमेंट ऑफ इलेक्ट्रॉन्स हो रहा है विच लीड्स टू द मोमेंट ऑफ करंट. अब हम इलेक्ट्रिसिटी दे रहे हैं बाहर से, तब जाके रिएक्शन होगी, तब मोमेंट ऑफ इलेक्ट्रॉन्स होगी, तब फ्लो ऑफ करंट होगा. Second very important thing is the direction of both electrons as well as the current is opposite as compared to what we have studied in the proper galvanic cell. When your E external is greater than E cell, flow of electrons takes place from copper to zinc. Now कॉपर इलेक्ट्रोड पे ऑक्सीडेशन हो रही है, इलेक्ट्रॉन्स जनरेट हो रहे हैं अब कॉपर इलेक्ट्रोड पे. जो लोड हो गया था जिसपे बहुत सारा कॉपर डिपॉजिट हो गया था, अब उसकी ऑक्सीडेशन हो रही है. सो कंज्यूम अब कॉपर होगा एंड डिपॉजिशन किस पे हो जाएगा? जिंक. फ्लो ऑफ इलेक्ट्रॉन्स टेक्स प्लेस फ्रॉम कॉपर टू जिंक. नाउ कॉपर इज योर एनोड, फ्रॉम एनोड टू कैथोड, एंड we know that current flows in the opposite direction, thus current will flow from zinc to copper, right? Zinc gets deposited and copper starts dissolving. This is very very important. ये तीनों diagrams A, B and C आप बहुत अच्छे से learn करोगे, knowing that what is the relationship between E external and E cell, and उस relationship के consequent क्या होगा cell में, क्या direction of the flow of electrons होगी and क्या होगी डायरेक्शन ऑफ द फ्लो ऑफ करंट, राइट? एंड जिंक यहाँ पे एनोड है, यहाँ पे कॉपर एनोड है, बिकॉज ऑक्सीडेशन जिस पे होगी वही एनोड है. सो आई टेकन दिस वेरी सिंपल कमर्शियल. ऑब्वियसली जो ये हम कंस्ट्रक्शन पढ़ते हैं गैल्वेनिक सेल की, ये पढ़ने के लिए है या लैब में एक्सपेरिमेंट करने के लिए है. कमर्शियली जो हम बैटरीज यूज करते हैं उनका डिजाइन ऐसा होता है. दिस इज अ वेरी वेरी कमर्शियल पिक्चर. जो सेल्स मार्केट में ऐसी दिखती है और अंदर से ये ऐसी होती है. हाउ डज द होल थिंग, हाउ द होल सेटअप वर्क? ये जो वेसल होता है इसका, दिस मेड अप ऑफ कॉपर. सो दिस कॉपर वेसल itself acts as a cathode, right? And inside it we have a porous plate. कॉपर वेसल के अंदर पहले कॉपर सल्फेट सोल्यूशन है, ऑब्वियसली विल नीड Cu2+ आयंस. फिर एक पोरस पॉट है. इसका जो पोरस पॉट है, पोरस इसलिए है बिकॉज इट विल एक्ट एज अ सॉल्ट ब्रिज. थ्रू इट्स पोर्स देयर विल बी द मूवमेंट ऑफ आयंस. उसके अंदर वी हैव डाइल्यूट H2SO4 इन विच जिंक रॉड इज डिप्ड विच एक्ट्स एज एन एनोड. सो जस्ट लाइक दिस, एनोड पे जिंक पे ऑक्सीडेशन होगी, कैथोड पे रिडक्शन होगी. दैट इज हाउ केमिकल एनर्जी will be used to generate electricity, and that is how these cells function, right? Again, this is very important. अब आपने galvanic cell पढ़ी, आपको उसका principle पता है, आपको उसको construction उसकी पता है, लेकिन अगर आपको represent करने को कहे, so there is a proper sequence. You cannot represent a galvanic cell randomly. You have to put all the components in a proper sequence, तब जाके वो correct representation होगी. This is how you do it. First of all, anode, the negative pole जिस पे oxidation होती है वो लिखा जाता है. Then we have two standing lines which represent the salt bridge. इधर कैथोड पॉजिटिव पोल जिस पे रिडक्शन होती है उसकी डिटेल्स लिखी जाती है. एंड एनोड में ऑक्सीडेशन साइड में आप कैसे लिखते हैं, पहले मेटल लिखेंगे, जैसे इस सेल में जो अभी तक हम पढ़ रहे हैं जिंक मेटल है हमारा ऑक्सीडेशन साइड. देन अ स्टैंडिंग लाइन, देन द मेटल आयन, इसी मेटल आयन की जो आपने सोल्यूशन उसमें इलेक्ट्रोलाइट का लिया है जिंक 2+, इन ब्रैकेट्स यू मेंशन इट्स कॉन्सेंट्रेशन. C1 विल बी द कॉन्सेंट्रेशन ऑफ the solution, the electrolyte on the oxidation side. Now we have two lines again which represent the salt bridge. On this side, what you write first is the metal ion with its concentration. Copper 2 positive with its concentration C2. Then standing line, उसके बाद metal. We have the metal here is copper. अब ये चाहे कोई भी ज़रूरी नहीं है हर वक्त आपकी redox reaction between zinc and copper ही होगी. They can change. So accordingly आप देखोगे oxidation half में क्या है, उसका metal slash उसके metal ions with their concentration, salt bridge represented by two lines. कैथोड में देखोगे आप reduction side में क्या है, उसके ions, पहले ions लिखने हैं यहाँ with the concentration, standing line and then copper metal. One important thing I would like to tell you here is that in this cell zinc की oxidation हो रही है and copper की reduction हो रही है. किस substance की oxidation हो, it depends on the nature of the other substance present. हम next एक दो दिन में electrode potential पढ़ेंगे तो that thing will be clear to you. Electrode potential की जो हम generally show करते हैं by using reduction potential term, we generally talk of it as the reduction potential. That determines कि किस substance की relative to another substance oxidation होगी या reduction होगी. Like जब आप copper zinc के साथ ले लेते हो, इनका relative relationship ऐसा है that zinc will get oxidized and copper will get reduced. अगर आप यही copper silver के किसी salt के साथ लोगे, silver और copper का relative relationship because of their standard reduction potentials ऐसा है that उस वक्त copper की oxidation होगी and silver की reduction होगी. So यहाँ पे रूट लर्निंग नहीं करनी है कि जिंक की हर वक्त ऑक्सीडेशन होगी, कॉपर की हर वक्त रिडक्शन होगी. इट डिपेंड्स ऑन what kind of a relationship as per as their electrode potential is concerned these two substances share. अब मैंने example सिर्फ इसका लिया because this is the most common galvanic cell and यही generally हम पढ़ते हैं, यही probably exams में भी आएगा. So you should remember this relationship. But we'll study electrode potential and this concept will be more clear. Now I have, since we have done electrolytic cells previously and now we did the galvanic cell, I've just used this diagram to elaborate on the main points of difference between the two. Electrolytic cell, we use electrical energy and it is converted into chemical energy. Here we already have a redox reaction which generates chemical energy that is converted into electrical energy. Now electrical energy brings about a redox reaction. It's a non-spontaneous reaction. आप जब electrical supply दोगे तब जाके reaction होगी. Here electrical energy is generated by a redox reaction. Redox reaction is spontaneous here. Anode is positive while cathode is negative. Anode is negative while cathode is positive. This is a very crucial point and you should try to understand it very, very well. In case of galvanic cell, they have written that anode is negative. Why? Because zinc की जब oxidation हो रही है, it's leaving behind electrons. This electrode is rich in electrons. That is why it is a negative electrode. So far this point is correct that in a galvanic cell anode is negative, इस पे oxidation हो रही है and cathode is positive क्योंकि इस पे reduction हो रही है. But इस वाले point को understand करना बहुत ज़रूरी है. Electrolytic cell में जब आप electricity pass करते हो, electrolyte dissociates into its component ions. Cations होंगे, anions होंगे. Anions will always move towards the anode. That is how इस electrode का नाम anode पड़ा, because anions will move towards the anode, right? Why do they move towards the anode? Because this anode is connected to the positive terminal of the battery. That is why you should understand by this point, anode is positive. What do we mean by saying that? Anode is positive in electrolytic cell. In an electrolytic cell, anode is linked to the positive terminal of the battery. That is why it is called as a positive electrode in an electrolytic cell, right? Now electrolytic cell में we take just one container, redox reaction उसी में होती है, and as you saw just now that galvanic cell में हम separate oxidation करते हैं and reduction. We have a separate oxidation half, we have a separate reduction half. We don't need a salt bridge in an electrolytic cell, right? We need a salt bridge to maintain electrical neutrality in galvanic cells. Now in an electrolytic cell, ions are discharged at both the electrodes. As I said, जैसे electricity pass होती है, electrolyte dissociate होगा, anions will go to the anode and cations will go to the cathode. So ions are discharged at both the electrodes. But in galvanic cell, oxidation यहाँ हो रही है and deposition सिर्फ cathode पे होगा. Ions are discharged only at cathode, right? These are some important points. You should remember these and go through this diagram also. You'll be able to compare them. And I think that is enough about galvanic cell, and you can give a little more time to this diagram जिसमें ये bubbles में इन्हें elaborately दिखाया है कैसे zinc oxidation हो रहा है. It's losing electrons and it's getting oxidized. Thus the electrode is getting depleted, consumed. These electrons move in the external circuit. They come here. यहाँ पे copper sulfate के जो copper ions होते हैं, यहाँ पे copper nitrate है कि copper ions होते हैं. They take up these electrons and copper बन जाता है, which gets deposited on the electrode, and that is how this electrode is loaded. This is your salt bridge. There's a movement of ions from this direction to this. Negative ions come to this and positive ions go here, right? This is the galvanic cell.